Okay, for number one, they say the greatest integer function. There's a footnote there in case you didn't know what that is. And by the way, if you didn't know what it is, you you might have a tough time doing the problem, by the way. So it's also referred to as a floor function, and there's other notation for it. I actually prefer this notation, but I rarely see it. All right? But anyway, let's take a look at it. And it says over here, the greatest integer function, blah, blah, blah. Find the nth derivative of this one, evaluate at 2.5. All right, so I don't just go to the whiteboard and take this and take the steps. So against number one, I'm given f of x equals, let's see what it equals. It equals, x minus x. Well, you know what I did? That's not true. It's not that. Let's go back over that again. So it's x minus the greatest integer function. I'm going to use this notation instead, by the way. That's also referred to as the floor, by the way. Okay, so what I'm going to do is I'm trying to find the nth derivative at 2.5. So then what I would say is we're on an interval, and the interval we're 2.5. I'm going to say we're between 2 and 3. So let's just talk about what the function looks like between the number 2 and the number 3. All right? Now, why do I say that? We're on the interval between 2 and 3. That's where 2.5 is. So what would f of x look like? F of x would look like x minus, well, if you're on the interval between 2 and 3, right, you have to start thinking about what the floor would be. Those numbers would be 2 point something up to 2 point something, right? It's always 2 point something. And what's the floor of 2 point something? It's just going to be 2. And that's to the nth power, all right? So then the question is, you got to get this nth derivative thing, and I'll go through that. We'll do one derivative at a time. And so I'll put the first derivative down. That's f prime. And yeah, I can't do n, but I can get a pattern for it. This will be n, x minus 2 to the n minus 1. The second derivative, that's going to be n minus 1 times x minus 2 to the n minus 2. Whoops. Let's keep moving. Let's do the triple prime. That's going to be n minus 1, n minus 2, and then x minus 2 to the n minus 3. So I'm starting to think that, maybe I could write down the nth derivative, f n. I'm going to look at this, and I start to realize that, the x minus 2 raised to a power is probably the easiest thing for me to look at. So, first derivative, n minus 1. Second derivative, n minus 2. Third derivative, n minus 3. Well, the nth derivative would be n minus n. Then I need to look at this thing over here, all right? And what are you going to get? Looking at it, it looks sort of like a factorial at this point, but not really. It looks like the beginning of a factorial. So n minus 1, there's 2 factors there. There's 3 factors over here. So I'd expect to see n factors. And if I did that, I hope you realize n factors, that's 1, that's the second one, that's the third one. And I'd march all the way down to what? Well, 1. Let me just point out what I mean by that. If you count the number of factors over here, there'd be n factors here. This is n factors. Again, I'm just looking for a pattern. This is 3 factors. Maybe I shouldn't have circled that. Maybe I should write down what I'm saying. 3 factors. You get the idea. 2 factors. I get the idea. 1 factor. Now over here, there's 0 factors there. All right, you can say 1. I guess you can say 1 factor. So looking at that, I'm going to say the nth derivative of this particular function is n factorial times x minus 2. Well, n minus n is 0. All right? So, there's no factors of x minus 2, so that means we're just getting n factorial. All right? So I got the derivative now, and the derivative is this. Thank you.